Okay, so we were talking about the minimum press capacity required for the two operations, and we said that we will compare the cutting lengths for the both cases. For both cases. So first, in case we want to cut at the same to perform the two operations of blanking and punching at the same time, then the total length should be equal to the perimeter of the outer circle and the perimeter of the inner circle. So it will be pi d outer plus pi d inner, which will give me the total length in case of cut, in case I want to perform the blanking and punching operation at the same time. And in this case, of course, I will need the highest capacity. I will need a force equal to 0.7 times the tensile strength times the area of cut, which is the thickness times L. And as you can see here, pay attention for units. So here, if I use for the tensile strength the unit of megapascal, and I use for the length, for each length, a unit of millimeter, then in total, my force will be in megapascal times millimeter squared. Okay. And in this case, I will have my force in Newton, because this is 10 to the power 6 Pascal. This is 10 minus 6 millimeter. So it will give me 10 to the power 6 times 10 to the power minus 6. So it is Newton, because Newton is Pascal meter square. Okay. So this will be the minimum press capacity in case I want to perform the blanking and punching operation at the same time. On the other hand, so this will save time for me. On the other hand, if I want to perform separately the two operations, then if you want the minimum force, the press capacity, the minimal press capacity will be determined by the highest cutting length between the two. And of course, the blanking length of cut is higher. It is pi times the outer, because the outer is higher than the inner. So then the press capacity in this case will be determined by the blanking operation. So we just do the tensile strength, which is the shear strength, which is 0.7 times the tensile strength, times the length of cutting operation in case of blanking, which is pi d outer, and times the thickness of your stock, which is 3.2. So we get then the press capacity. And of course, if you have this force, it is more than enough to perform the blanking and punching, because the force required for punching will be lower than the force required for blanking operation. Okay. Any question on this problem? Okay. Now, determine the requirement for the blanking operation in problem 16.3, given that the stainless steel has a yield strength of 275 megapascal, shear strength of 450 megapascal, and tensile strength of 650 megapascal. So here also we want to determine what is the corresponding press size that we should use. Okay, so what is the capacities, what is the minimum press capacity that should be used? So going back to problem 16.3, in problem 16.3 we are performing a blanking operation, and to determine the minimal press capacity, the minimal force to be used, we should determine what is the cutting length. Okay, so the cutting length here is equal to the perimeter of the desired part, which is 50 plus 25 plus 25 plus 35 plus 25 again. Plus, well, if you want, due to symmetry, you can directly say it's 2 times 50 plus 2 times 25 plus 2 times 25 again, plus this length, which is 35, and plus 85. You get the total length of cut. Once you have it, knowing the material thickness, and they gave us now the shear strength, you just say that F is equal to the shear strength times the thickness, which is 4, times the perimeter length, which is calculated as we said here based on the perimeter of the blank part. Now, in this problem, no need to use the formula 0.7 times the tensile strength because they gave us the shear strength. So here, if you compare, you can compare that if you do 0.7 times tensile strength, 650 times 0.5, okay, 0.7, it will not give you exactly the value of 450. So here, because this is an approximation, since the shear strength is given, no need to use the tensile strength formula. So I will directly use it. I will directly use the shear strength. So I have here first, as we said, the force which will determine the capacity of my press is equal to the shear strength times the thickness times the length of the cut. The length of the cut is given by adding all sides of my, calculating the perimeter of my blank part. And then once I have all the information, I can calculate the press capacity of for this blanking operation. Okay. Any question on this? So these are the problems concerning for practice on blanking. Next time we will introduce the banding operation formulas and do the practice problems on them. Okay?